Well, hello. I'm Doug Soldat. Had the pleasure to be Michael's advisor. Michael is he's amazing. Last night we were looking over his presentation, and he's asking me for advice. And the whole time I'm thinking, this should be flipped. I should be showing Michael my presentation, and he can give me advice on it. So I'm presenting on behalf of another one of my PhD students, Chiu Zhou, who couldn't be here today. And so she and Michael did their PhDs together. They're both leaving me at about the same time, and so it's a kind of a sad time in my lab right now. But so proud of both of them. Michael earned a Fulbright fellowship through the U.S., which is a really, really prestigious award. The U.S. gives its young, bright scientists permission and funding to travel to different countries and collaborate with international scientists. So he'll be flying back to Wisconsin and packing up and then coming back to the University of Oslo in August. So that's where he's headed for now for a year. And then Chiu, I learned recently, just accepted a job as a assistant professor at North Carolina State University. So she'll be starting there in September. And so her work was on another big problem that we have in the turf industry is how do we apply the right amount of nitrogen? It's one of the trickiest problems that we have. We have a tremendous variability, and this is data that Michael collected as part of his resource survey, about nitrogen application, kilograms per hectare, on greens, tees, fairways, and roughs. And so let's just, for the sake of simplicity, look at nitrogen on greens, which is mostly what we're going to be talking about now. You can see the different regions of the courses that participated in this study range tremendously in nitrogen applied. So here in Denmark, we have golf courses applying less than 50 kilograms per hectare up to 200. If we go to East Texas, we have a golf course around 100 and another one around 500. So a factor of 5 amount of variation. And that's common throughout all the countries. Now, if you look at the gray bar here, this is about how much nitrogen fertilizer is applied to corn in Minnesota, which is near where we, it would be in the Midwest, okay? And the gray is about how much variation the farmers have in their nitrogen application. So certainly, yeah, some farmers apply more and some farmers apply less, but you can see that their variation is much tighter. And if you look at the variation in fertilizer in golf courses in the Midwest, you have some courses at maybe 25 kilograms per hectare and then some at 175. So there you go. There's another 5-fold increase in nitrogen. So statistically we would talk about that variation in terms of this thing called the coefficient of variation, or CV. So you can see that the corn coefficient of variation is much, much lower. They're tighter. Why is that? Well, because they're growing a crop for yield, and they get a certain price for corn, and they know how much the fertilizer costs, and it's a very simple economic transaction. Where in turf, we don't have that, and we talk about turf quality, and we have different expectations, and so maybe this is right. So maybe it's okay that we see this much variability in golf course nutrient use, but I have a feeling that that's not quite it. I think part of this is because we have very poor guidance for how much nitrogen to apply. And the reason we have no guidance for it is because there's no soil test that can tell you how much nitrogen you should apply. It's based on things that are difficult to describe and quantify. So the way that I've been thinking about maybe what we need to do as an industry is thinking about nitrogen inputs and outputs. So if you remove this much, then maybe that's about how much you should put back in. And I think that might be a guide that can get us to apply nitrogen more consistently. So basically, if in the case that you're applying more nitrogen than you're removing, the nitrogen's accumulating in the system. You might have too much growth or excessive thatch and eventually nitrogen leaching. But if you're applying less nitrogen than you're removing, your soil organic matter goes down. Maybe turf quality starts to thin out. So probably, in most cases, you want your additions to equal your removal or losses. So that's the trouble, and we've been talking about measuring growth rate and clipping volume, and that's why I think that concept is so useful, because when you're measuring your growth rate, it's also a very useful estimate of how much nitrogen you're removing, and then that can guide the amount of nitrogen that you return to your system. And so as a practitioner, you're probably thinking, yep, that's what we do, right? We look at our growth rate and we're using nitrogen to get it in the right spot. So I guess the thing that we're trying to add is a degree of precision to that. So we use artificial intelligence and machine learning and these fancy sounding words, but basically computers can give recommendations that are more precise and can help reduce or maybe standardize nitrogen additions. So clipping volume, how many people in here measure clipping volume? Hands up high, so high and proud. Not too many. So I would encourage you to do this. And so this is a slide from Chris Trittabaugh, golf course superintendent in the Midwest U.S., who will promote this and says it's one of the most important things that he does. And it's really simple. And so why don't you do it? These are some responses like, here, I can't find a bucket, okay? That's a bad one. It takes too long. It doesn't take too long. If you're measuring soil moisture on your greens, it's easier than that. It's like 5 times faster than that. You literally, instead of dumping the clippings in the back of the utility vehicle, you dump them into a bucket first, and then you dump them into a utility vehicle. It's not accurate enough. Well, it's more accurate than just looking, for sure. So I know, and I hear that all the time, but like, oh, we can tell I get a half a bucket per green or something like. Your greens are different sizes, right? And so you cannot tell the level of precision just by looking in the baskets. And I think, the thing I would encourage you to do this is like, if you have a triplex mower, you're going to find that the 3 reels may not have the same amount of clippings in them. And that should bother you, right? You should want to set that mower up so they're getting the same amount of clippings. So that's another reason golf course superintendents do this and stick with it, is because they realize it makes their evaluation, their maintenance equipment better. How do I keep track of the data? I think this is a big problem. And so when we're talking about precision turf management, scientists are asking you to collect data and input data and interpret data. It's a big job. And so I think one of the biggest needs is for software development tools to automate all that stuff. And people are working on that. And then, people say, I don't need to do it, I can already tell. And Chris wrote this, not me, but I agree. You can't tell like this. You do not see the fluctuations that you think you do. So when we grow grass, and Chiyu spent a ton of time just collecting clippings from plots and measuring how much clippings were collected and how all the different factors influence growth, because we want to be able to predict it. Ideally, you don't have to collect clippings. If we just know the weather conditions and your management and the number of rounds, we can just predict fairly accurately how much grass you grew and therefore how much nitrogen you might need to apply. So this is the thing we learned. What are the factors that influence creeping bentgrass growth the most? And so we put all that information in the computer, and the computer spit this out. The top 2 things were relative humidity 3 days ago, relative humidity 5 days ago, the temperature 3 days ago, and the temperature 4 days ago, and the relative humidity 4 days ago. So wow, that's what really drives the fluctuations of growth, is the weather 3 and 4 days ago, the temperature and the relative humidity. Those are the most important things. Then all the way down here is nitrogen rate. So if I would have asked you what influences your grass growth the most, you probably would have said my fertilization, the nitrogen. That's important, but it's not as important as the weather was 3 or 4 days ago. That's what you're seeing, and that's how long it takes the plant to react to that weather event. NDRE, this is a reflectance device that you could stick on a mower that just measures how green the grass looks. That showed up here. The wind showed up. The ET showed up 3 days ago, but all the weather events were all 3 and 4 days ago, which was really interesting. And then traffic influenced growth as well. So all these things influence turfgrass growth. You're trying to hit a growth target, and that's why we need to use artificial intelligence and machine learning, I think, to give us guidance on what to do. So that's what we tested. We looked at 4 different strategies for applying nitrogen on golf course putting greens on creeping bentgrass. We used this machine learning approach that Chiyu developed. This is what we think is the best we can do with modern technology. We use the PACE turf growth potential model, which I know some people are using. I'll describe what that means, but it's a method rooted in the temperature and the growth rate of grass that sort of inspired us to do this machine learning approach. The third way is the way that all of you do it and the way that I do it on my research plots. So our research plots, I've been at the University of Wisconsin for 15 or 16 years, and I apply approximately 10 kilograms per hectare every other week as urea. That's kind of what I've settled on, is like, that's perfect for me, and I'm fairly confident in it. So this is the kind of gold standard that we're trying to beat. Can we be even more efficient than what I think is perfect? And then a sensor-based method was our fourth one. So we put foot traffic on these plots, about 1,000 rounds per week, using, just Nick's in the back there, one of the people that we asked to strap on golf shoes. The funny story is you can see the construction in the background here. So there's like all these people like right by the research station, and they'd see us like doing this for hours. And they never talked to us about it, but we always wondered, I wonder what they think of us right now. Trust me, it's important. I'm going to be in Copenhagen in a couple of years talking about this. All right, so then this is Chiu here, collecting the clipping yield. So in order to make sure that this model is working, we have to know the actual grass growth rate. So she collected a mountain of clippings. This is the NDRE sensor that we used, and we measured soil moisture 3 times a week. And then our machine learning model, it's really, we've published this, and it's something that doesn't exist in a user-friendly format yet, but like I said, software development needs to take this and run with it. But basically, it just requires 7 days of weather data, a sensor measurement if you have one, soil moisture content if you have it, the amount of traffic and how much nitrogen you applied if you have that information. And the model will still work on just weather data. So like, you don't have to have any of this extra stuff, but this extra stuff makes the predictions even better. So you plug that into a machine learning statistical, and then it tells you, here's how much grass we think you grew. And what we found is that this was very accurate, like 80% accurate. So then that's how we fertilized. We basically said, we're going to fertilize every 2 weeks, which is how we do it normally on our research plots. And the amount of nitrogen we apply for the machine learning method is how much clipping biomass the computer thought we grew over that 2-week period times the estimated tissue nitrogen content, which is about 3.9%. So you don't have to measure that. That's another talk I'll give this afternoon that shows you can just use 3.9%, and that's going to be a good average. So the growth potential model, oh man, I'm going to struggle here for time. The growth potential model just uses temperature. So if you're cool season grass, it says that there's a maximum clipping yield. In our case, it was about 44 grams per square meter per 2 weeks. And again, we multiply this number, 44, by 3.9, which is going to be like 16 kilograms per hectare per 2 weeks. So then if the growth potential is 100%, we'd apply that much. If the growth potential is 50%, we'd apply half that much. So it's a temperature correction on a maximum fertilization rate. It's really easy to use. You could use this right now if you want. And then we used my method, like I said, 10 kilograms per hectare every 2 weeks. That seemed to work pretty good for our location. And then we used this spectral method, which says we'll do this method. We'll use the experience method. But if the NDRE says the grass is really green, we'll skip an application. Okay, so it's sort of like a modification of the experience method that you could probably also implement at your golf course right now. So yeah, we generated a lot of different clips. So these are just the 4 different nitrogen fertilization methods in 2020, 2021. And you can see that these are the amount of clippings that we generated. And this is why I'm saying you can't tell just by looking in the bucket, because your clippings vary by a factor of like 5 day to day. And when I ask you guys if they do that, you always tell me no, it's consistent. It's a half a bucket every time. But when you measure it, the variation is tremendous. And you can see that the paste turf model in this case produced a lot of clippings, and the sensor-based approach produced the least, and there's some in the middle. And that's what's so hard about nitrogen, is because I can't tell you that any one of these is right. They're just different. Okay? So this is the amount of nitrogen that was applied over these 2-year periods. So for the paste turf model, it was about 120 to 140 kilograms per hectare per year. And then with the machine learning method, is the one in the green, it was close to half of that amount. So, and then the my way is the purple line. This is the way we'd normally do it, about 100 kilograms per hectare per year. So using the machine learning method produced a similar but significantly lower amount of nitrogen. So then the question is, what impact did that have on the turf quality? Because my experience method is based on the turf quality that I think is right. This is NDRE, this is a sensor-based, we'll skip that, I'll just show you the picture. So the machine learning method looks really similar to the experience, the white ones. So I can't really tell visually the difference between experience and machine learning, but the machine learning reduced my nitrogen input by 25%. So instead of putting 10 kilograms per hectare per week, it was like some weeks it would be put down 8 kilograms per hectare or 7.5. And something I would never do, right? Just keep it simple, this much nitrogen. But the computer's saying, why don't you just put a little bit less? And the end result was, over a 2-year period, we saved 25% nitrogen, and the grass looked exactly the same. And I think that's what we're trying to be more efficient. That's how computers can help us get there. So here's the turfgrass quality. The Experience University recommendation, 7.4. It's got an A-B by it. Machine learning approach, it's 7.1. It's got a B. But we had average annual fertilizer use, which is 100 kilograms per hectare using my way, the Experience method, that I think is really good. Machine learning was 75 kilograms per hectare. So the computer saved us nitrogen and didn't influence our turfgrass quality. The machine learning model is really accurate. So I didn't spend a lot of time talking about paste turf temperature method because we found that that model overestimated the turfgrass growth. So the predicted divided by the actual clippings is here. So paste turf was overestimating the amount of clippings we generated. And that's expected because it only uses temperature. The machine learning stuff is using all the weather data, 7 days of weather data. It's using traffic. It's using all this stuff. And the predicted divided by actual is almost perfect. So it was very, very accurate at predicting our clipping yield. So where turfgrass is headed is, I think, soil testing. I didn't give this talk about phosphorus and potassium because we have fairly accurate soil testing guidelines that say if you're below these levels, you need to use phosphorus and potassium. If you're above it, don't worry about it. But for nitrogen, we just don't have that. So we need to think about growth targets, collecting clipping volume, figuring out what the right growth target is, and then use our nitrogen and our growth regulators to achieve those growth targets on a monthly or weekly basis. So this is the goal. I think if we use these new precision nitrogen methods, we're going to see maybe not shrinking as tight as the corn is, but we're going to shrink some of these bars, and people are going to be putting down nitrogen more accurately and more uniformly. So with that, I'd like to thank you for your time, and maybe we have time for a question or two.